Good morning, friends and dear students. It gives me immense pleasure to be here again for my course Aircraft Systems. Today I am in my next topic, which I am going to take about a case study on aircraft DC power system. In this I am going to discuss about how the electrical power is generated on aircraft, how it is distributed, how it is protected, how it is transformed. All these topics I am going to cover. As you know, my name is Dr. Yagya Dutta Dwivedhi. I am professor in Institute of Aeronautical Engineering, Hyderabad, India. Topics and the CO mapping of this, as it belongs to the Unit 2. So, in this course, outcomes are CO2 for all these topics. In this, I am going to take about the first topic is elements of aircraft electrical system. Then I will go for power generators. Then third one is the control devices. Then power conversion systems, power protection systems. Then last but not the least is aircraft electrical systems. In this, I am going to show how the electrical systems are distributed for different purpose of the aircraft. So, aircraft electrical systems I am going to discuss here, and this you can see here that this is the just a block diagram of different types of electrical systems and their location I am representing here. This is the aircraft. If I see here, here A is AC generator. This you can see here. These are near the engines. All the AC generators are here. Then DC generators are also here in the engine. Then APU is here. APU. Okay, here. Then TRU is here. Then batteries are fixed here. This is the battery. Then DC bus bar, if you see, they are the DC bus bar. Then AC bus bar is here. This is the AC bus bar, and this is the DC bus bar, a very small bus bar. Maintenance bus bar, and this AC bus bar. DC bus bar is here. This is the DC bus bar. This is the AC, and this is the maintenance bus bar. So these are just few items which I can show you here. Okay, so this you can see the red color is a maintenance bus bar. This is the maintenance bus bar. This is the dotted line is a AC bus bar. This firm line of black is your DC bus bar. And here E is a batteries. These are the batteries here. Batteries are placed. If you see here A, B, C and D and E. So A is the AC generators. This you can see here. AC generators are there. Then DC generators are here. These are the DC. This is the AC and this is the DC generators. APU generators are here. This is the APU generator. And these are the TRUs. So this I have given some very important components of electrical system of the aircraft which are shown in this diagram. Now, outcomes of this lecture. So, what you are going to, students are going to learn by this lecture. So, students will be able to describe the basic component of aircraft electrical system, explain operation of electrical system, interpret aircraft electrical diagram, select proper size of wire for installation, describe basic causes of electrical systems and the malfunction. These are the few outcomes which the learners able to get by this today's lecture. Now I will go with element of aircraft electrical system. What are the parts or what are the components which are related to the aircraft electrical system? this is depicted in this slide. So an aircraft electrical system is mainly composed of power source. So what are the main thing for aircraft electrical system? First thing is a power source. Then we have some components. These components will be having the control devices, conversion devices, and the protection devices, power distribution systems, and the electrical load. These are the topics which are given in this today's class. Electrical power sources, if you see, we have the electrical power sources on an aircraft may be classified into two groups. One is the battery, another is the generator. Main two types of power sources are there. First and foremost and very important for emergency operation is batteries, and for small aircrafts these batteries are sufficient to run the aircraft, to start the aircraft. Batteries are the two types in aircraft, that is the lead acid battery and nickel cadmium battery. Two types of batteries are used. If you see about the generators, we have the DC direct current generators and the alternating current generators. These two types of generators are installed in the aircraft. I have shown you here in this diagram, this AC generator and the DC generator, and here are the battery. So these three things are the power sources which I am explaining here. These are the generators, AC generator and the DC generator, and the batteries we have the lead acid and the nickel cadmium batteries. So if you talk about the batteries, we all know batteries in our mobile also, in calculators or any other sources we use the batteries. So batteries are also used in aircraft. A battery is a device that converts chemical energy into electrical energy. So what is the battery? There is a chemical inside, some water or some chemicals or some acids, and there are some materials. That materials, they are the chemical materials. The energy of that chemicals is converted into electrical energy. It is a power reservoir that stores energy in a chemical form. It does not produce energy. So it is a reservoir. It is a power reservoir that stores energy in the chemical form. It does not produce energy. Its functions are, what are the main functions? To provide power when no other power source is available. Main primary source of the powers are generators. If generators are not working, in case of emergency, when other sources are not there, this will provide the power for the emergency systems to assist in damping transient load in the DC system. And in DC system, the batteries are also damping the fluctuation of the loads as and when load is increasing or decreasing. Okay, this also to provide a short-term source during emergency condition. If your DC or AC generators or any power other sources are not working, for short time, for few minutes, your aircraft's emergency systems will work and you can land within that given stipulated time. The capacity of the battery is measured in ampere hour, AH. Ampere hour means it is measured like AH. How much AH is there? Its normal rate is a little over 24 volt DC in a 28 volt DC system. So the normal rate is 24 volt DC in a 28 volt DC system. When your battery is fully charged, a fully charged battery should have 28 volt DC. That is requirement, but it can work up to 24 volt DC. It can work. It is automatically recharged when the engine driven generator is operational. So as and when your generators are operating, your batteries are charged. Two types of batteries are used in aircraft. One is the lead acid battery, another is the nickel cadmium batteries. So any one type of battery we can use in aircraft as per the given condition by the manufacturer of the aircraft. Here I am going to talk about lead acid battery. So in this, what happens that it is usually found in piston aircraft. So in small aircraft we use the lead acid. It is made up of cells which have positive negative plates of lead and filled with electrolyte of sulfuric acid and water. So in this lead and H2SO4 with water is made. It has corrosive effect. Each cell has approximately 2.2 volt but is simply rated as 2 volt. So if you want to 28 volt, you need 14 cells. Okay. It has corrosive effect. Frequent total discharge and remaining battery in discharge condition for a long time will shorten the life of the battery. So if your frequent total discharge, if it is happening and the remaining battery in discharge condition for a long time, will shorten the life of the battery. So battery life will be shortened. Here it is shown here. One is the plate. These are the plate here. 2 is the cell container. 3 is the supporting ribs. These are the ribs which are supporting. 4 is the vent cap. Here it is a vent cap. Gas will be out from here. 5 is the terminal post. Here is terminals are here, plus or the minus. 6 is cell cover and 7 is separator. So these are the parts of your lead acid battery which I have explained in this diagram. Next is nickel cadmium battery. Mostly we use this nickel cadmium battery which is very robust. It can be used for longer time. So nickel cadmium batteries are mostly used in aircraft. They are the most common type of battery used in turboprop and turbojet engine. I have seen, because I have worked in turboshaft engine or helicopters, so there they use the nickel cadmium battery, and so they are most common type of battery used in turboprop and turbojet engines. They provide electrical discharge at a high rate without voltage drop and accept high charge rates that shorten recharge time. So they can be recharged very fast. They provide electrical discharge at a high rate without voltage drop. Means voltage drop will be very less. Even it is discharge battery and accept high charge rates, and it can be charged very fast. They may be subjected to thermal runaway condition caused by overheating, in which the battery destructs itself. So thermal condition, heat condition is not good for this type of batteries. They will get overheated and the battery destructs itself. So battery will damage itself if the temperature of environment is higher than the required. Here also, if you see nickel cadmium battery, I have shown here. This is the cell terminals. Here we have the wind pipe. Here we have the main container, main connector, and here is a container. So in this box, different cells are here, and these things are used for this purpose. What are the generators? So we have learned about the two types of batteries. Now the second source of the power is generators. Generators also, we have the AC generator and the DC generators. So a generator is a machine that converts mechanical energy into electrical energy by the process of electromagnetic induction. So for the generator, we have to rotate the magnet. If you rotate the magnet in the coil, it will generate the electric power. So that is the basic principle. So a generator is a machine that converts mechanical energy into electrical energy by the process of electromagnetic induction. They are driven by engines and are sometimes by APU. So these generators are rotated by the help of the engine or sometimes auxiliary power unit. A generator must be rated at adequate amperage to drive all the operating components on its circuit. The current required to operate each electrical component is known as a load. So what is the load? How much current each and every component is required to operate that component, how much current, and accordingly it is called how much load it is taking. All generators produce alternating current naturally. The method which is used to take it from the coil will determine if the generator provide AC or the DC to the circuit. So every generator basically it provides the alternating current. But what method we use to take out the power, that will make that whether it is AC or the DC to the circuit. If a commutator is used for this purpose, it will be a DC generator. So if we are using for this purpose a commutator, that commutator will generate the DC generator. And if we use the slip ring, then a AC generator, it will generate the, it is called the AC generator. So if we are using this commutator, it will generate the DC, and if this, it will generate the AC. So only this component make the basic difference between these two. So now I will discuss about the direct current generators and how these things are working. This I am going to discuss in this slide. Commutator in a generator converts the AC current to the DC current. So the commutator is the main component which makes AC to the DC. DC generator is designed to supply nearly constant voltage. They generate normally the constant voltage. Usually the voltage is 28 volt DC. Normally this DC generator 28 volt DC, but sometimes we need 270 volt DC also for modern aircraft. Okay, so but there are 270 volt DC systems developed recently. The high voltage DC also used in few of the aircraft like F-22 and F-35. This they are using American made aircraft. They use 270 volt DC system. They supply current up to 400 amperes. Okay, their current is 400 amperes. Most aircraft do not have a separate DC generator, but AC produced by DC generator is converted to DC to power DC system. So most of the aircrafts, they have the AC generator. However, there are few equipments which are operated by the DC. So this AC can be converted to the DC power as and when required. So this you can see here, that here is the magnet and the coil and it is moving. This will give the magnetic field is here, and this magnetic field will, and there is a coil and it is given the rotation by the engine. This coil is moving in this direction. This is shown here, and the magnetic field from here to here, it is there. A current will be produced in this ammeter. Okay, that is the principle of the DC generator, and here is the commutator. This commutator will give the power in the one direction only. So that is the objective. So here this operation of the DC generator, we can see here that A, B, C, D and E, and here this you can see as it is rotating in this direction, it is moving, then at the horizontal, then it is again here same point, again in another direction, and again it is going. So like this, it will only one direction, it is not going in this direction. If it is going this direction, it becomes the AC. So it is, and if we have the more number of coils, So this will go like this, like this, like this, like this, like this, like this, like this. So it will become very smooth. So that is the operation of the DC generator of the aircraft. Producing steady DC. So we have seen one. Now here we have the multiple coils. This you can see 1, 2, 3, 4, 5, A, B, C, D, E. 5 coils are there. So if you make like this, it will become steady and smooth. It will look like this, very, very smooth. DC power is achieved. So as you have more number of coils, your revolutions per revolution, it will become very smooth, and it called the steady state DC current. Now I will talk about the AC generator. These AC generators are also called the alternators. So just now I told that most of the aircrafts, they have the AC generator only. Alternators, and these alternators, they produce the AC current. This AC current can be converted into DC as and when we required. On most large aircraft, high load electrical devices are usually AC powered. AC is produced by an AC generator, which is usually called alternator. So this generator, AC generator, is also called the alternator. AC generators use slip rings instead of commutators to provide the current to the circuit. So in the DC we use the commutator, but here we use the slip ring. We use the slip rings, and this will provide the AC. Alternator generates 3-phase current. So 3-phase 115 volt AC with 400 hertz. So this is the rating of the aircraft alternator or the aircraft generator. So alternator generates 3-phase current, and standard aircraft voltage is 115 volt AC with 400 hertz of the frequency. Here basic AC generator. Here this you can see that this is the slip ring here. So north and the south, and this coil is moving, and with the engine this coil is rotated, and here is the magnet, and it will produce the current. This current will go from here to here and here like this, and another it will go here. So it is called the brush. In this brush, these things are matched, and your AC current is achieved. Now I'm going to discuss about modern electrical power generation system. So we have discussed about our batteries, the two types of sources. One is the battery, another is the generators. In battery we have the two types, lead acid and the nickel, cadmium. For the generator also we have two types of generator, AC generator and the DC generator. Most of the aircrafts are operated, and most of the electrical and avionics equipments are operated by the AC power supply. So it is very much essential that this AC has to be converted to the DC, because few equipments of the aircraft, they are operated by the DC also, especially the avionics equipments and the lightings, they are operated by the DC supply. But for the modern power generation, what type of systems are there? And modern electrical power generation and their types. Mainly two types of electrical power generations currently in use on aircrafts. One is a constant frequency integrated drive IDG, CFIDG, constant frequency integrated drive generator. Then second one is a variable speed constant frequency generator. So constant frequency integrated drive and variable speed constant frequency generators are used. I am going to discuss about the first type, that is the constant speed integrated drive generators. So it is essential that the alternator output have a frequency of 400 Hz with a very small tolerance. Thus, rotational speed of the alternator must remain absolutely constant. So this is very important, that In this case, if it is constant speed IDG, it is essential that the alternator output have a frequency of 400 Hz with a very small tolerance. Thus, the rotational speed of the alternator must remain absolutely constant. This is accomplished by using a constant speed drive CSD unit between the engine and the alternator. So we have a small unit. That unit will give a constant speed, whatever speed of the engine may be. But this constant speed drive, a special type of gearbox, this gearbox will give always a constant speed, so that a constant frequency of 400 Hz can be achieved by the constant speed IDG system. So this constant speed drive provides a constant alternator RPM within a specified engine RPM range. So this is the importance of the IDG. And alternator and a constant speed drive unit combination is called the integrated drive. So alternator and the CSD, constant speed drive, they are in the one unit, and this is called the IDG, integrated drive generator. CSD is a hydromechanical operated. So this constant speed drive is what? It is a hydromechanically operated and needs to be maintained in terms of oil level and oil cleanliness. So this inside this oil level, and oil should be very much clean and very much pure. Then only it will able to maintain a constant speed. It is most commonly used power generation method on today's turbine power aircraft. So most of the turbine power aircraft, they use the IDG, and this I have shown here in this a small picture of IDG, which is taken from the reference. It is a reference 3. So this you can see here. Here a mechanism is here. Inside this some oil is there. It is hydromechanically operated. It will maintain a constant speed for a given range of engine speed. Now next is the variable speed constant frequency power generation. So in this, speed will vary, but frequency will be constant. I want 400 Hz. 400 Hz I should get it. So it is called VSCF, variable speed constant frequency generator. In this method, the variable frequency power produced by the alternator is converted to constant frequency 400 Hz 115 volt AC by solid state device electronically. So here we use some electronic devices. These electronic devices will convert to 400 Hz and 115 volts at any speed. Thus, there is no need for CSD unit, because CSD unit itself is very big. It needs oil and all. So this cost and the weight of the aircraft is increased. It is a new technique and limited in use. So still it is in the limited, but in future it is going to be used for many operations. Here I have shown one small picture of VSCF, that is variable speed constant frequency generator, and this makes electronic device in this a constant speed and a variable speed, and the constant frequency is obtained by help of this mechanism. So till now we have discussed about different power sources, different AC and DC. In AC I have discussed about generators. I have AC and DC generator. In AC we have seen that variable speed constant frequency generators and constant speed variable frequency generators we have seen. Now power generation of and the control of this power. Power produced by generator is usually controlled by generator control unit, GCU, generator control unit. So for every generator there is a control unit, and that will try to control the power. The main function of these devices are act as a voltage regulator. So what it is doing? Act as a voltage regulator, direct current to battery for recharging, provide circuit and generator protection by disconnecting the generator from the system when electrical abnormalities occur. Act as a voltage regulator, direct current to battery for recharging, provide circuit and the generator protection. These are the function of the control. Power control devices which are used in the aircraft. So these devices are used to initiate and control the operation of the circuit. Control devices includes switches, rheostat, relays and the solenoid. These are the control devices. Switches, it will on or off. Rheostat, it will change the resistance and accordingly the RPM, these things will change. Relays are there to delay the or give a sequence of operation, and solenoids are also used for this purpose. So first I will discuss about the switches, and few switches I have shown here, and these switches are taken from the reference number 2. A switch is used to start, to stop or to change the direction. So a switch is used to start, to stop or to change the direction of the current flow in the circuit. So what is the purpose? Either it can start, it can stop, or also it can change the direction from here to here or here to here. So it can do these different roles. It can start, it can stop, or it can change the direction of the current flow in the circuit. So that is the purpose of the switch. Here we have the toggle switch. It is shown here. This is the toggle switch. So what is the purpose of? It will make on or off. If you press like this or you press like this, on, and another side is off. So toggle switches, they are on off switches and extensively used in aircraft electrical system. So many switches you will get like this. Next you have the push switches. They are used primarily for operation of a short duration. So pull and push. So if you press it, it will be on, and if you pull like this, it will be off. Rotary switch I have shown here, which you can see here. This is the rotary switch. This is the rotary switch, and when it is necessary to select several conditions for a circuit, a rotary switch may be used. So just you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, the rotors are there. This you can change wherever you want. This will be connected to the respective point. So this you can make it like this, like this, like this. This you can rotate and it will be indicating which switch it is connected. So these switches are also used to many places in our aircraft. So these are the switches. Now we have the rheostat, then we have some relays, then we have solenoids. So this rheostats control the amount of current that flows through the circuit and used as a dimmer device for instruments and cockpit line. So this rheostat are used to dim or make the light more or less. So if you just pilot will rotate 1, 2, 3, 4, 5 high and then 1, 2, 3, 4 low, it will be very much dim. So this rheostat are the current circuit, and the resistance here, it will from here to here, and accordingly this variation of this thing will change. So rheostat control the amount of current that flows through the circuit and used as a dimmer devices for instruments and the cockpit light. So instrument, if you want less light or the more light, and you have to change. In our car also these things are available. Then we have the relays, then electromagnetic switching devices which are used to remotely control electric circuits carrying large amount of current. So these relays are electromagnetic switching devices which are used to remotely control electric circuit carrying large amount of current. So next is solenoid. Solenoid remote control devices quite similar to relays, but they are designed to move a shaft over a short distance. Thus, solenoid are used as a mechanical control devices to operate hydraulic or pneumatic valves, locking pins, etc. So it will move in the one direction. So there is a coil like this, like this, like this. A metallic coil is there, and it will inside there is a rod. So if you give the current, this rod will move either this direction or this direction. So if the lock pin is there, like your landing gear, it has to go and it is locked. So if you want to remove, the solenoid will be used. So pilot will give and this solenoid will pull that lock, and your landing gear will be unlocked. And after this hydraulic pressure, it will start falling down. So in those type of situation, we use the solenoid valves. Now next is the conversion devices. So there are many occasions with an aircraft electrical system where it is required to convert power from one form to another, means AC to DC or DC to AC. Typical examples of power conversions are convert from DC to AC power, conversion from 115 volt AC to 28 volt DC, conversion from one AC voltage level to another, battery charging 115 volt AC to 28 volt DC. So these are the four types of conversion which we do normally. That is the AC to DC or DC to AC, from 115 volt AC to 28 volt DC, conversion from one AC voltage level to another AC voltage level, battery charging from 115 volt AC to 28 volt DC. So these are the battery charging requirement. Following devices are used for these purposes. The first one is a transformer, rectifier, transformer rectifier units, that is called the TRUs, inverters and the transistors. So these are the devices which are used for the conversion from one type of power to another. First one is the transformer, then second one is the rectifier, then transformer and rectifier, that is called the both TRU units, inverters and the transistors. So these are the few units. Now I will discuss about the transformer. This is shown here, that is the primary coil and this is the secondary coil. Here is the iron core. So if you give here some voltage, as per this coil here, the voltage will increase or the decrease. Okay, so that is the purpose of the transformer. Transformer used to change AC voltage level, means high to low or low to high. Rectifiers used to convert AC into high amperage low voltage DC. So if it is a rectifier, then it will convert AC into high amperage low voltage DC. TRU, it is shown here, that is called the combination of transformer and the rectifier units, and used as a main unit to convert alternator output to DC in an aircraft. So AC to DC, it is transformed or converted by the TRUs. Inverters convert 28 volt DC power to 26 volt AC power, particularly for flight instrument, or 115 volt AC. So the inverters are converting DC to AC. DC to AC, sometimes 28 volt DC to 26 volt AC, or sometimes 115 volt AC, as per the requirement of particular system. Then we use the transistors, electronic devices that control electron flow and convert AC to DC. Transistors are used to convert from AC to DC. Here it is shown the TRU, that is the transformer and the rectifier unit, which is used to convert from alternator AC to DC, AC to DC, and this is to voltage change. Mostly it is high to low, but we can do low to high also. There are step up and step down transformers are there. So here inverter and the components, it is shown here. This you can see here, that here we have the commutators are here. This you can see, either resistors are there, head assembly is there. These armatures are here. Here also, this is the housing. Here we have the fan. Here is the rotor, yoke assembly, resistors, brush, and so this is a inverter and its component which is shown here. Now I will talk about the protection system. So we have discussed generation, control, and all. Now how to protect the system? Our electrical system should not get burned. So we need the protection system and the protection devices. These devices are used to protect circuits, cables, and the system components from damage due to failure. So if your systems fail or there is short circuit, other systems should not burn. So we need some protection devices. Few important protection devices are fuses, circuit breakers, diode, and GCUs. So these are the few protection devices. So what is the fuses? Fuses are designed to protect the cables against the flow of short circuit and excessive current. They break the current and stop the current flow when the current exceeds a predetermined value. So if your circuit is 5 ampere, so we will put the 5 ampere fuse. If the current is going more than 5 ampere, it will burn and your system will be safe. So these are called the fuses. Now CBs or circuit breakers, they have same function with the fuses. The difference from the fuse is that they are resettable, while a fuse must be replaced. So this CBs, we need not to replace, only just you have to press it and it will work. Or it is falling down, just you have to make it up. But it is function is same as the fuses. In olden days we used to have the fuses, but nowadays we are using the circuit breakers. Next we have the diodes. They are the electronic equivalent to the check valve in hydraulic system. They allow electricity to flow in one way only. So these diodes are used to make sure that the current should not go back. It should go forward. So in these cases, only diodes are used. Bus bar. What is the bus bar? This you can see here as an analogy of bus bar. We have seen this in our houses. We have this power sockets. So these power sockets, our aircraft, we have the bus bar. This bus bar is like this power sockets. We can take the power for different systems like this here in our this bus bar. It is a power socket. So in most types of aircraft, output from the generator is sent to one or more conductors before distribution throughout the systems. These conductors are called the bus bar, and they act as a distribution center for electric power. A bus bar system is set up so that each power source supply one or more specific buses. This is my last slide, and in this I am going to depict the aircraft electrical systems and how it is working. So here we can see that we have here left generator and here the right generator. We have here APU. Here we have the control unit here. Here also, here also. So every generator should have a control unit. Left generator bus, right generator bus, and center bus. You understand the bus? Bus means it is from here taping of the power is taken. Just now I have shown. This is the bus. So from here, left TRU and the right TRU, transfer rectifier unit. So it goes to left main DC bus and right main DC bus. Here is the main DC bus. This you can connect to this each other. Then it goes to the left secondary DC bus, right secondary DC bus. Here also we have the same type of system here. This from here it goes to the main battery and backup battery. Here it goes for the power supply. From here it goes to the left battery bus, right battery bus, left inverter, right inverter, left AC bus, right AC bus, low voltage AC bus up to 26 volt. Then step down transformer, low voltage AC bus. So here different types of a simplified electrical system is shown, and a power distribution, power generation, power control, AC to DC, power conversion, every items of my previous slides are explained in this diagram. These are the references for my this lecture. Moir I and the Seabridge A, Aircraft Systems, Mechanical, Electrical and Avionics System, Professional Engineering, Publishing, London. Second is again the same author, Moir and the Seabridge, Design and Development of Aircraft Systems and Introduction. And the last one is the I have taken a slideshare.net, Taushik Khan, 10/9 Aircraft Electrical System. I have taken from there. Any questions you are welcome to ask. It will be my pleasure to reply your questions on aircraft systems. My email is ydwivedi@gmail.com. Try to like and subscribe this channel. It will encourage me to do future better way. I can deliver in better way. Thank you very much for joining my class. See you again for my next lecture. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.